In this video, we are going to demonstrate that the angle between the north celestial pole and the horizon due north of you is always equal to your latitude. So how could we go about thinking about this? Well, here is a picture of the Earth. We're looking at the Earth from the side, so I could say here is the North Pole, and here is the South Pole of the Earth. And based on how I drew this picture, I could say the North Star is going to be somewhere 500 light years in that direction. So this is to the North Star. Now, based on how I drew this picture, the equator of the Earth is going to run around the Earth and then behind the Earth, something like this. And the center of the Earth I'm drawing to be right here. And we're going to place ourselves somewhere in the northern hemisphere on the edge of the Earth in the way that I drew this picture. So let's just place ourselves right here. So I draw a little person there. Now, how do we demonstrate that the angle between the north celestial pole and due north, basically your horizon, is equal to your latitude? Well, first I'm going to draw the latitude in. So if I were to draw a line from the center of the Earth to my location and compare that to the equator, then I will say this is my latitude. I don't know what this number is. I know it will be between 0 and 90 degrees. I'm going to call it theta. Theta is usually just, it's a Greek letter and it's usually used for some angle. So my latitude equals theta. Okay, now I'm going to look at the way I drew this picture from my perspective. What would I see? Well, I can't really see around to this side of the Earth because it's over the horizon. From my perspective, my horizon is going to be something like this. So I could see this way up to this way, but anything down here is blocked by the ground. From my perspective, it's almost like it's below ground. If I wanted to see somebody over here, I would be able to have to somehow magically see through the Earth, which you can't do. So the direction of the horizon that is due north of me is this way over here. So this is to the horizon. However, if I look at this picture, I could say to the North Star, from my perspective, is also going to be straight up. So the North Star is going to be directly above me in that direction. Technically, I am a little bit away from the North Pole, but the North Star is 500 light years away. 500 light years compared to this distance, even though we're talking about 100 or 1,000 miles on the Earth, this distance across the Earth is nothing compared to hundreds of light years. I could say these two lines are perfectly parallel with each other. So these two lines are perfectly lined up. So actually, for this video, I didn't draw it quite so neatly. I'll draw it neater. So these two lines are perfectly aligned with each other. Okay, how am I going to think about this? Let's draw another angle. So let's take a line from the center of the Earth directly to the North Pole. We'll make it red since we're going to visit Santa Claus. And let's call this angle over here phi. Phi is just another angle that is unknown, different from theta. And if I look at this picture, I recognize that I have something that looks like this. This is a 90-degree angle. And if I were to draw something like this and put a line in between them, I could say if this is theta and if this is phi, theta plus phi must equal 90 degrees. I don't know what theta is, I do not know what phi is, but I know they must add up to 90 degrees. How am I going to think about this now with this picture? Let's take ourselves and the line that begins at the center of the Earth and goes to where we're standing. Let's continue this line upward. So from my perspective, this line is directly overhead of me right now. So this line is directly overhead of me. And this is basically what we said is the zenith. And if I look at this picture and think back in high school, if you took geometry, you might have seen if I have two lines that are parallel with each other, and if I have another line intersect, whatever this angle is going to be, this angle will be the exact same thing. And that's basically what we have in this picture, where here are my two parallel lines, and here is this diagonal line that intersects. So if this angle is going to be phi, this angle must also be phi. Now, if I look at this picture and I say, well, here is directly overhead of me to my zenith, here is not the perfectly horizontal along the horizon from my point of view, this is making a 90-degree angle. Right here, from here to here, I have a 90-degree angle. So if this is 90 degrees in total, and this is this angle phi, which I do not know what it is, that's okay, because therefore this angle over here must be theta. Because I don't know what this angle is, I don't know what this angle is, but I know they must add up to 90 degrees. And if theta plus phi is 90, and this is phi, and this entire angle is 90, this must be theta. So if I were to erase a few lines, and just to explicitly demonstrate this picture, right along here, this is to the horizon. So this is to the horizon. Along here, this line right up here is to the North Star, which is at the North Celestial Pole. And the angle between these two guys will be theta, which is the same as my latitude. And as a result of this angle right here being phi. Now, as I said before, in this course, you're not going to need to work through anything like this. If you want to watch this video again, feel free to do so. It is important to me that you believe what I say, not because I say it, but because it comes natural to you. So I just want to demonstrate that the angle between the horizon and the North Star is equal to your latitude.